Okay, as it says here in the title slide, today I'm going to discuss Type 2 dilemma zones at high-speed signalized intersections in Poland. But when we talk about high speeds, we're talking about speeds higher than generally in non-built-up areas. So the speeds on average with signaled intersections will be 70 kilometers an hour. Higher than that are very rare. And if we relate those speeds to real speeds achieved by drivers when crossing traffic light intersections, these are much higher because drivers tend to violate the speed limits. What is the dilemma zone? This is a term that has been known since the 1960s. It was researched in detail mainly abroad, but it's not very commonly seen as a research subject in Poland. In the past, Dr. Gondek in our department used to do it in the kinematic approach. When we approach an intersection with traffic lights, when green is on and we see that it changes to yellow, we have to make a decision. Do we go or do we stop? Now, depending on the decision that we make, we may meet with various consequences. Either we'll enter the intersection in yellow or red, or we have to brake. And that braking will be uncomfortable, potentially dangerous, depending on the negative acceleration. So here we come to type 1 of the zone, which is the length. How long should the yellow light be? In Poland, this is unfortunately impossible because the yellow light has a constant length. The second type, probabilistic, in Poland has not been used. Hence the idea of doing this research in our conditions. Let me show it on a graph. In the kinematic approach, we have a curve that shows the deceleration curve, which is safe, and the crossing path, which will allow the driver to enter the intersection during the yellow light. If the length of braking will result with entering in yellow, we still have the first dilemma. About 45% of the decelerations fall into that zone. If we add drivers that stop, they usually are not analyzed when we run conflict analysis because they stopped. So we can't really measure their behavior in terms of conflict. So if we compare the proportions under the given terms of one group and the other, we can find the probabilistic zone. This is again the dilemma of the driver. Should I stop or should I drive? But this time in terms of the probability of me taking a certain decision. If I can't predict what decision the driver will make. This is the second zone. And the second zone is mainly used for traffic control. It allows the improvement of safety by using adaptive traffic lights. Therefore, work was undertaken to define the dilemma zone for the Polish conditions, which will then make it possible to adjust the control system to the actual behaviors of Polish drivers in Polish conditions. So the research was done into the behavior of the drivers when they see traffic lights turned from green to yellow and what sort of factors could affect their decision at that point. That is why my presentation, that we prepared together with my colleagues, is mainly to identify facts, and it can be later used for further analysis. But I'm going to stop at the data collection. In order to carry this out, we tested 25 intersections, of which half were located in Kraków with a higher speed limit, and the other half on national roads outside urban areas based on video filming. We were registering the reactions of drivers to the display of yellow traffic lights, what speed they were traveling at, what was the distance from the intersection, what were other circumstances, in order to define the factors that affect driver decision and therefore define the probability of a given decision. We used the binary logistic regression model because the variable is binary. If they have two options, either I stop or I keep driving, then obviously this is the formula of choice. The other elements that will affect the decision were related to the vehicle itself, the characteristics of traffic on the crossroads, the geometry of the intersection, and the surrounding features. We have some examples here that were used to analyze whether they might affect the driver's decision. But there were very many. This is just a sample. There are very, very many, especially in terms of the geometry of the intersection and its surrounding, because our intersections are so variable that it's possible to test features that are not often demonstrated in research or tests done abroad. Usually the geometry of the intersection is not emphasized, and there's reason for that, but I'll discuss that later. Let's move on to the results of our analysis. I will present those variables that proved to be statistically significant as affecting the probability of the driver either to stop or go. Let's show it in the form of a bar graph. These are individual probabilities. Here we have the odds ratio. We have those variables that were significant statistically. If we have the value above 1, that means that I'm increasing the probability that the driver will stop. What contributes to it? The distance from the stop line at the moment the traffic lights change, the presence of a supplementary light, and being in built-up areas. The other factors increase the odds that the driver will cross on the yellow or red light, which is an increase of velocity, a heavy vehicle as opposed to lightweight vehicle, and what is typical for Poland, not shown in foreign research, is the presence of other vehicles in front of us or behind us. They usually are conducive to making the decision to jump the lights, to cross the intersection. I think that's self-explanatory. Like the signal, the further it is, we usually evaluate the distance to the supplementary traffic light rather than to the stop line, because the traffic light is much easier to notice. So depending on the location of the supplementary traffic lights, that may affect the decision. And these are the dilemmas. Because we are short of time, I'll probably not discuss it in great detail. So we have the probability of the driver stopping depending on the distance. It's worth noting that these borders by standard for the type 2 dilemma are 10 and 90% of the drivers that stop. So if we have a 3-second distance from the stop line, 70% of the drivers will decide to continue driving. So they will be entering in the last second of yellow light and often in the beginning of the red light. In case of 4 lights, still 40% of the drivers will be entering the intersection, and that will be entering the intersection on the red light. The other graphs show the impact of the other factors, and I'll skip those for now. But I'd like to comment some more on this graph, where we compare the probability curves relative to research conducted in other countries, conducted in different conditions. What differentiated these intersections? This is all done for approximately 70 kilometers per hour. Compared to the UK, the US, in 2 cases where the traffic lights, the yellow light lasted 3 seconds or 4 seconds. We demonstrated that our drivers operate in a less homogeneous manner, even though we have the same length of the yellow light throughout the country. We have a higher probability of stopping from a smaller distance, sometimes very abrupt stoppage. In case of larger length from the stopping light, when the green is off and switched to yellow, in Poland there's more probability that the driver will keep driving. These results are actually similar to those foreign tests that use 4-second yellow light. We sometimes meet the practitioner's approach saying that the 3 seconds is very good because the drivers won't know what it is anyway if it's variable. So if they know that it is 3 seconds, it will allow the drivers to make better decisions. But our research does not confirm this assumption. Actually, they suggest that with higher speeds, one should actually consider extending the length of the yellow light duration to 4 seconds. In summary, I'll also cut it a little bit short. These are the relevant figures about the locations of the dilemma zones. This zone is much wider than the kinematic that is usually used in Poland, but it's not characteristic in any way for the local conditions. But the most important conclusions are the following. We have yet another confirmation, numerical, that with the certain type of interpreting the results, that the uniform length of duration of the yellow light is not recommended. And our drivers actually behave in a less uniform manner in their reactions to yellow light than foreign drivers. These are the main conclusions that I wanted to present. As I said, the type 2 zone dilemma is mainly used in traffic control, but maybe this information can be presented during future conferences. Thank you very much.